Hi everyone, we are talking about integrating inverse trig functions, and first we need some integral rules. So here, if I have the integral of 1 over the square root of a squared minus u squared, where a is some constant and u is a function of x, then my integral will be arc sine of u over a plus c. Right, same deal here, where a is a constant and u is a function of x. The integral will be 1 over a arc tangent of u over a plus c. Right, and then the last one here, this is my arc secant. So 1 over a arc secant of the absolute value of u over a plus c. All right, so let's do an example. Here I see that 4 is the same thing as 2 squared, and then obviously x squared is x squared. So this looks a whole lot like my arc sine formula. Right, now I'm going to do a u sub here. I'm just going to write out my work. Okay, so I'm going to let, first of all, I established that a equals 2. Now I'm going to let u equal x. All right, that means that when I take the derivative of both sides, du equals dx. And so I can just make a straight substitution here. So this is going to be the same thing as essentially the integral of du over a squared minus u squared, where a is 2. Okay, that's what I just established here. Now you don't really have to write this step, I'm just writing this out. And so my final answer will be arc sine of x over 2 plus c. Alright, so because this was a fairly simple one, you could have jumped straight to the answer. Let's do another one. Alright, so here I see that this is 2 squared and this is 5x quantity squared. So this time, again, I'm going to let a equal 2, but I'm going to let u be 5x. Okay, that means that du is 5 dx, so 1/5 du equals dx. Alright, so now when I make my u sub, I'm going to have this 1/5 in front of my integral. Right, and so I'll have du over the square root of a squared minus u squared. Alright, so this matches perfectly with my arc sine formula. So I get 1/5 arc sine of my u, which was 5x, and my a, which was 2. And just remember to put plus c at the end. Alright. One more on this page. Now this looks a whole lot like arc tangent because it's plus and there's no square roots. Okay, but this time it's a definite integral. So I realize that this is 3 squared, so I can pretty much jump straight to my answer because I know that a equals 3. Okay, so from arc tangent, I know that I'm going to have 1 over 3, because that's my a value, arctangent of u over a. In this case, u is just x. So x over 3. And I'm evaluating from the square root of 3 to 3. Okay, so I'm going to write out my work. I'm going to plug this in. I'll bring this 1/3 out of the whole thing. And I have arctangent of 1, because 3 over 3 is 1, minus arctangent of root 3 over 3. Alright, and we simplify this and we get 1/3 times pi over 4 minus pi over 6. Alright, let's keep going. Now we're getting into something where it's not exactly obvious where to go. Alright, so what we're going to do is force this to be a quadratic so that we can get it to look more like our inverse trig formulas. Okay, we want some squares. Okay, so we're going to complete the square. We're going to force this to factor out nicely. So what I'm going to do is rewrite my integral. Minus 4x, and I'm going to introduce a plus 4. Okay? Now, you could think about this in a couple ways. You can think about it as splitting up the 7 into 4 plus 3, or you can think about it as the 7's still there. I'm adding 4 here, so I need to subtract 4 here, and 4 minus 4 is 0. Okay, however you want to think about it, it's up to you. But I'm going to write it out this way. So I added 4 on the inside of my parentheses, and I'm subtracting 4 on the outside. So it's still the additive identity property. Okay, I'm just adding 0 here. Okay, and what this does is it allows me to factor this nicely. Okay, so I end up with dx, and 7 minus 4 is 3, and then x squared minus 4x plus 4 factors to x minus 2 squared. Right, so in this case, a is the square root of 3, because the square root of 3 squared is 3, and u is x minus 2. Okay, that means that du is still dx. And so when I make my substitutions, I have the integral of du over a squared plus u squared. So this is still my arctangent formula. And so when I just plug my values in to my arctangent, this is what I get. All right, so again, we're picking values for a and u, and then we're plugging them into our formula. That's pretty much it. All right, let's keep going. Okay, so we're forced to complete the square again. And so first thing I'm going to do, you don't have to do this, is I'm going to factor out that negative. Okay, so I see what I got going on down here. And so when I complete the square, I see that I'm going to have to add a 9 in here. So I have 1 over negative x squared minus 6x plus 9. Okay, but the way that we're going to counteract this is I didn't really add 9, I added negative 9. Okay, so this 9 is really negative, so I'm going to do a plus 9 on the outside, because 9 minus 9 is 0. And so now what I have is 1 over the square root of 9 is just 3 squared. I'm going to put that here, minus, and then right here I can factor this into x minus 3 squared dx. Make that a little longer. Okay, and so this looks like my arcsine. So I have arcsine of x minus 3 over 3 plus c. Right, and in this case, a was 3, u was x minus 3, and we just plug into our formula. All right, one last one. We have the inverse of arc cosine over the square root of 1 minus x squared. Okay, so we're going to do a u sub here. I recognize that the derivative of arc cosine looks a lot like this. Okay, so I'm going to let u equal arc cosine of x. Okay, that means that du is equivalent to negative 1 over the square root of 1 minus x squared dx. Alright, so this looks very, very familiar. So I'll just move this negative over. Alright, so I see that this situation right here is equivalent to negative du. Now, because we did a u sub, we have to change our bounds. So I'm going to write that out. So when x equals 0 and when x equals root 2 over 2, right, we got to do a little bit of calculations there. So u will end up being pi over 2 if I plug 0 in to arc cosine of x. If I plug root 2 over 2 into arc cosine of x, we get pi over 4. Okay, so now I'm going to rewrite my integral. So my negative will go out here. U du, and my new bounds are pi over 2 to pi over 4. Okay, because I have a negative on the outside, well, I just see that my bounds are a little ugly the way that they are because it's going from a bigger to a smaller number. So I'm going to flip them. And remember, if you flip them, then your integral will be, well, negative, or you'll put another negative there. And a negative times a negative is a positive, so this will end up being positive. So we can do that. That's just using our integral rules. And from here, it's a pretty straightforward integral. All right, so we end up with 1/2 pi squared over 4 minus pi squared over 16. Right, and that is it for this. See y'all later.